Peter, Daniel, everybody else that's joined, really good to see you all. And thanks once again if you're a returning viewer of DevOps for Everyone. And hello if it's your first time, where have you been? But I'm pleased today to say that we're joined by a really special guest and a company that I've been following personally for a while to talk about a product that I think is going to really take off. It's version 2 now, so version 1 must have done well. The company itself is a silver member of the Cloud Native Computing Foundation, so pretty well engrossed in the open source and Kubernetes community just by that. There's thousands of users on their Slack channel, hundreds of developers have contributed to their open source projects. Microsoft, Ticketmaster, go on their website, you can see the pretty cool customers that they work with. And to have Peter, one of their developer advocates here today, talking to us about one of their key products is a real exciting thing. So Peter, I won't take up any more of your valuable time.
Cool. Thank you for that intro, Joe. All right. So as Joe mentioned, I'm Peter. I work for Ambassador Labs. I'm a developer advocate. So today we're going to be talking about Telepresence 2.0. As I mentioned, I'm Peter, developer advocate, Ambassador Labs. In the past, I've done product education, customer success, network engineering. I graduated from coding bootcamp back in 2019. You can find me at Peter ONeill Jr. on pretty much all social channels. Currently do the whole digital nomad trend, working remotely, currently in the lovely city of Antigua in Guatemala. And yeah, so let's actually talk about Telepresence now. So what is Telepresence? Telepresence is a cloud native tool. It's used to connect your local laptop to your remote Kubernetes cluster. This is going to give you all the networking benefits of being in the cluster, but directly on your machine. This helps you create simple feedback loops for easy debugging purposes. And at the end of the day, it's just designed to save time and frustration when writing code for cloud native applications. This is Telepresence 2.0. We had Telepresence 1.0, which was written in Python, and we received a bunch of feedback from our community and from the users wanting very specific things. And so the team took it upon themselves to rewrite the entire binary in Go to make it faster, to make it a little bit more reliable. We wanted to add in a few extra features as well. We rebuilt it with collaboration in mind, and we also rebuilt it to better support complex network configurations. Specifically, VPNs were one area that users were reporting that they were struggling with. So we wanted to make all these things a big improvement. On the right here, we have the infrastructure or the kind of architecture of how the Telepresence 2.0 works. And so to break this down, we have the laptop on the top there, which is running the Telepresence daemon locally. And as you're working with services, as shown to the left of that, that gets piped over into the cluster represented by the square box here into a traffic manager, which is a deployment in the Ambassador namespace that we use to do a lot of the traffic manipulation. And as you want to intercept a service, which essentially means that there is a service on the cluster that you instead of traffic being directed to that service, you want it directed to your local machine, we pop in a little item called a traffic agent, which then helps direct that traffic down to the local machine, intercepting that service and allowing you to work with a service in conjunction with everything else in the cluster. And we'll cover a little bit more as we go and explain this in a little better detail. And so what this gives us, one of the things that helps me the most is essentially just once you're connected, you have Telepresence connect into the cluster, and that networking is then established. DNS resolution is the first thing I'm always reaching for. It is the one where you can never really predict DNS. For some reason, it always ends up being DNS. This is one of my this one poem definitely sums up DNS for me. As a network engineer for quite a while, and this one was a serious problem where it's just no matter how many times you think you've checked DNS, this always came back to DNS. So having a tool like Telepresence that connects you into the cluster, you can reach all of your services by the fully qualified domain name, or directly reaching into specific namespaces, or even shorter, once you have those intercepts set up, then you can reach your services directly just based on their service names. So once you are actually developing code for a cloud native application, one of the things that that can really throw you off is not having a great parity between your local dev environment and your remote and your production environment, or your development environment and your local environment. And so getting this parity kind of down packed is definitely essential. So with Telepresence connected, what you're going to have is you're going to have access to any external dependencies that are only connected to your cluster. If you are mounted to an external database, or you have specific network integrations to your cluster that you are never going to get on your local machine. Once you are connected with Telepresence, you get access to any of those external dependencies. And if you are doing value mounts for any of your containers, you can then mount these also locally down to your machine, and you can inspect these as if these files you can inspect these files locally on your machine as the containers in remote clusters would see them. The last part is getting the environment variables kind of copied directly down to your machine. So getting a local subshell running your local service, but with all of the environment variables from your remote cluster in that local subshell really gives you peace of mind knowing that you have all the settings that will be running once this service is running in your remote cluster. And so the default mode of Telepresence is the intercept. I've touched on this a couple of times, and now here's a graphic to kind of show this a little more clearly. Once you start an intercept in the default mode, which is the unauthenticated mode, what's going to happen is all traffic for a specific service, particularly here, we're showing the data processing service, which is a demo app, our EduCorp demo app that we like to use a lot. And so what happens is all traffic comes in from the ingress to the front-end service, and instead of reaching for the normal data processing service, Telepresence then intercepts all of that traffic, sending it down locally to your local laptop, running your development version, your local version of the data processing service, and allowing you to get that very, very fast feedback on how is my local service going to work when other services like a front-end Java service or a back-end data store are also connecting to it. And so it gives you that clarity of how your local service is going to work when there are other dependencies, and not needing to spin up all of those dependencies on your local machine. So you don't have to have the entire application running locally. You can have just the service you want to work on, and then get those external requirements pulled down so that you can see kind of the full picture. And then the second mode, very similar to the first intercept, except that in this collaboration mode, what you're going to have is you can route only certain traffic, right? It's more of a personal intercept, where Telepresence now says because it's in an authenticated mode, Telepresence can say, oh, I know who this user is. I know this user is Peter, and I know that we only want to direct this certain traffic to this user. So what's going to happen is Telepresence is going to inject headers into the request, and from those headers, Telepresence will say either this traffic is destined for Peter's local machine, or it'll say that these headers, or it won't see the headers, and traffic will be processed as normal. And so this gives normal users or other developers who are using the same cluster and even the same application the ability to use the application unaffected, while one developer is intercepting and receiving some of that traffic. This is one way that you can really collaborate with other developers or other users in your company, where you can give them a kind of a preview. So we call it the preview link URL, where they can see whatever you're working on. You share this link with them, and it sends them all the traffic going down to your local machine. And then you can compare that to what it looks like without it, just by going to the normal ingress or normal front-end service. And so just to wrap this up before I move into doing a bit of a demo and showing a few of these features in a little more details, Telepresence is here to create a fast feedback loop when writing code. It allows you to write the code, see how it's affected by the other services in your cluster, and then go right back to coding more. It gives you direct access to your clustered networking for fast debugging and just overall, like it is designed to save some time. First thing is just the simple Telepresence Connect, and this is establishing that network connection between your local machine and the remote cluster. This is hooking up a local telepresence daemon to the traffic manager that we showed in the architecture diagram earlier running in the remote cluster. So now my local machine is able to see everything that's running in the cluster. This cluster is actually pretty empty right now. So this is the Edgy Corp app where I want to create some services and kind of just show that once for services, Telepresence can see them, and Kubernetes or kubectl get services. These are those same services and deployments that Telepresence can see in the cluster, and so showing that they are available to you now locally as well. So we can kind of see the fully qualified domain function. If you are reaching out, the Kubernetes service is always there, and you can see reaching out fully qualified domain name. And so what I'm going to show next is external dependencies. This is one where if you do have something like you need to connect to a very specific URL, you can use these by creating service. And so say what I needed to connect to was getambassador.io, and creating that with the A8R service name. This will allow me to, so showing here the service that we created, which is reaching out to getambassador.io. And now that becomes available to me at the A8R.default. So if this was an external dependency where my cluster only had access to that URL, I would then have access to it on my local machine going through the cluster. Next thing I wanted to show here, volume mounts. And this is if you have data, some sort of config map for your services in your cluster, and you want to see this locally, right? So we're just going to create a config map here. I borrowed this from okay, so it's already exists. And let me make this a bit bigger for everyone. All right. So already exists there. And what we want to do is we're going to mount to a deployment, and then we're going to check it out locally with Telepresence. With this is a very simple YAML file. I'm creating this deployment called the Nginx deployment. It is mounting that config map, which we just showed, called game vars, borrowed from the Kubernetes documentation, and mounting it here. The services, exposing it in the services, how Telepresence will route the traffic through the service to the deployment. So what we'll do here is with Telepresence, I'm going to intercept that deployment, send that traffic down to my local machine, but I'm also going to add in here, I want to mount any of the volume mounts from that container onto my local machine so that I can then inspect it. I'm mounting it at var temp nginx. You can just set this to true and it will automatically choose a random location. So now we see inside etc config, like as if it was inside the container, it would be in that same location, etc config. And we can see that all of the string literals from the config map here, do a quick comparison here. We see that all the config map config items are showing up here locally on my machine, making it very easy to inspect what's going on from the command line for any of these containers. The next thing I talked about in the slides earlier, environment variables, getting to copy your remote containers environment pretty much verbatim and then bringing it down. So I'm going to apply this config as well. Also borrowed from the Kubernetes documentation, their sample environment container. This. So we're creating the deployment here and a service to expose it. And now that that is created, I'll do a telepresence list. I've shortened it to T, kind of just save some typing. And this is still listening. We don't need this, so we can leave the other intercept. And we can start to intercept on this environment demo container. And we can pass it into bin/bash. We can pass the vars directly into a subshell by specifying --bin/bash. So now telepresence is spinning up this subshell. So now I'm in a bash subshell as specified here. And if we do an env and then grep for demo, we can see that the environment variables that we wanted to pass in are now popping up in our local subshell here, along with the other variables that Kubernetes itself drops in. And so this gives us that feature parity between our environment parity between our local system. You can also pass this into directly if you want to run your service. If it's a Python service, you just start the Python service with Python, passing that in here as a command, or if it's Go, passing in with Go run. And so getting those commands and piping in all of the environment variables directly into them. And this is not the only way. You can also pipe these into var files as an env file, as a JSON file, but getting them down to your machine. So with that, I'm going to exit out of this subshell. And what we want to do next is kind of just the last feature that I was explaining is the selective intercept based on headers. So we applied this locally already. We already have the EduCorp app running. We can see here the data processing service, the very large Java service as the front end, and the very large data store as the database. So what we'll also do is we'll grab the code for this locally. Then we will authenticate with Telepresence, log in. And we see that now I am successfully logged in. Telepresence dashboard at any time will bring you back to this cloud preview page. And so here you can see any authenticated intercepts that are running. So let's leave the previous intercept. Already out of it. It closed when I exited the subshell. So now we can do a telepresence, or let's actually open up one more window here. What I want to do is, with this process, I'm going to be running, so I want to run my Go process locally here with the EduCorp sample app. So if I was working on this, running it locally, and now we're going to use Telepresence to pipe some changes through. So now what I want to do is intercept on this. I'm going to give it the very large Java service as the ingress default. I'm going to use port 80 to HTTP, and not going to be using TLS. And the default hostname is fine. Now Telepresence is going to set up that header-based routing so that we can reach my local service and we can separate that traffic from the normal ingress traffic. All right, and here we see the headers here. This is the headers that it will be separating it on. And with the preview URL here, sometimes it takes a second for it to spin up. Also look at is the very large Java services running on 8080. So with the very large Java service here, I'm using Telepresence to reach the front-end service for our EduCorp app. All right, what we will do instead of using the preview URL, we are just going to manually inject the headers ourselves to check this out, kind of give you a better look under the hood of how this works. So with this, I want to modify headers, view options page, and here, what I want to see is specify that the very large Java service is what we want to add the headers to. The X intercept ID is the header key here, and the header value, is this string right here. And now we see that it's sending this traffic down to my local machine. So the ingress, this ingress with the headers is now reaching my local machine. And to show this a little better, what we can do is we can make a change to my local app here. Let's modify it so that we can see a difference. Let's make it blue instead. Save that. My local service has rebuilt. And we can refresh and see that now my local changes with the ingress and the headers being routed down to my machine are instantly being showed with the front end service here. And if we look at this, so let's just open up another browser now that's not going to have the headers injected. We can see that without the headers, traffic is unaffected and being routed through the service, the data processing service in the cluster, which is showing the green variables. And on the left here, we have my local service running, showing the blue variables. So one application in the cluster, but you can have multiple people working on it because those headers will route only the necessary traffic down to the desired individual that wants to work on it. Okay, and that is the end of my demo here. Yeah, so you can find me, I'm active on Twitter at Peter ONeill Jr., or you can find me LinkedIn or any other social media channel. I'm pretty much Peter ONeill Jr. In most places, but Twitter is where I'm most active.